On the back of the orbiter, okay, you have 3 Space Shuttle main engines. They're simply called the Space Shuttle main engines. That's their official name, SSME. They're liquid fuel rocket. They run on liquid hydrogen and liquid oxygen. Okay, liquid fuels are nice. They're easily to store. Just require a spark in order to get them go. This is liquid propane. Boom, spark, it goes. Okay, nice thing about liquid fueled engines. You can throttle them up and you can throttle them down just like you do a car. Okay, we do that during launch. Okay? But they're not that powerful. When we're inside, we'll discuss the amount of thrust that you actually get from a liquid-fueled engine, okay? Now this is propane. Our regular engines use liquid hydrogen, liquid oxygen. All that is pumped from the external tank. There's no fuel on the orbiter for those engines, okay? So, stick birdie right there. In this balloon, I have one of the 2 fuels. I don't have oxygen, I have hydrogen, okay? So, if I put a spark in front of it, in this case from our flamethrower, it's going to explode, okay? So we're going to show how that works. Whoa. Okay, so liquid fueled engines, remember, require a spark and you can throttle them up and down. Alright, the other fuel system we have, solid rocket boosters. You guys will be firing some rockets later on during the week. Okay, who's ever fired a model rocket before? Okay, you guys know that they're a solid fuel, right? Mm-hmm. Solid fuel rockets, like our 2 SRBs that we have on the shuttle, they're essentially giant fireworks. Okay? Just like a firework, they require a spark to start. In this case, it's an electronic trigger. Okay? When you press this button, it sends a spark, ignites the engine. Now, just like a firework, you have no control over the engine. Once you light it, it goes until it's done. There's no stopping it. Okay, so no turning on and off, back and forth. Okay, and it goes till all the fuel is gone. So it's very little control, but it's like a firework. So, countdown from 5, 4,
3, 2, 1.
Right? Doesn't last very long, but it is powerful enough. Just this engine can take a model rocket about 600 feet. Okay? So, they burn very quickly, but they have very high thrust. Now, the last fuel system. It's actually one that we don't use during launch. It's used in on-orbit operations. If you look up and see Pathfinder or look later when the weather's better, there's 2 small cones by the tail above the main engines. Those are the OHMS engines, okay? Then there's 44 smaller holes, a lot of them are on the nose and some near the tail. Those are the RCS engines, okay? There's 44 thrusters. Those are for your little movements and everything. They run on a hypergolic fuel. Nice thing about hypergolics is they do not require a spark. Once you mix them, they will normally spontaneously combust. Now the actual chemicals they use on the shuttle are so highly toxic to humans that we don't even use them here. I'm using a different chemical combination.
That's why they're...
how it goes.
Isn't that why they're cleaning up the RCS engines on the retired shuttles?
Yes, that's part of the reason they have to make sure they're clean before they go to a museum. So it's a really nice system. It's the same fuel system we use for landing on the moon and taking off from the moon. All you gotta do is a very simple engine. If you look in the Davidson Center, we have 2 of the engines for the Apollo days. Very simply, just mix the 2 fuels and boom, you go. It doesn't take much. Okay, so that's what we use while we're in space. So, quick review. Space Shuttle main engines, liquid fuel. Okay, you can control them, but they still require a spark. Solid rocket boosters use the solid fuel. Okay, high thrust, but not a lot of control. And then the OHMS and RCS engines using the hypergolic fuels. That's what we use, okay, when we're actually in orbit to move around and everything. So, let's head back inside.
All right,